I gave you an example or a couple examples of free fall problems. I want to give you one that's maybe a little bit more complicated. I'm standing at the top of this cliff or at the top of this building, and it is my favorite building, or it quickly will become. Let's make this thing 20 meters tall. I'm going to have a couple of different objects. I'm going to have a blue ball that I'm going to just drop. I'll have a purple ball. That gets thrown upward at 10 meters per second. And let's have an orange. That shows up pretty well. Ball that's thrown downward at 10 meters per second. Maybe I want to know find the time difference between impacts. So what I'm looking for is the amount of time that it takes each one to hit the ground. I'm going to set up my table because that's how I'm starting these problems pretty much always. I'm going to have a y initial, y final, v initial, v final, acceleration, and time. I'm going to need some kind of an axis system. So I'm going to say let's let upward be my positive y-axis, and let's let the ground here be y equals 0. Now I'm going to set up my table. I can do this for all three right in the same table. Blue, purple, orange. Don't necessarily need 3 separate tables. For all of these, my initial position is going to be 20 meters. I'm starting all of them at the top of the building. For all of them, the final position is going to be 0 meters. The initial speeds we're going to get to, the initial velocities. The final velocities, we'll get to those too. The acceleration, all of them, once they are in the air, are subject only to gravity. And the times, those are what I'm trying to find. Next, my initial velocity for blue is 0. My initial velocity for purple, and that was just because I was dropping it. My initial velocity for purple is going to be 10 meters per second because I launched this upward in the positive y direction. My initial velocity for orange is going to be 10 meters per second, but I threw it downward, so it's going to be negative 10. I don't know how fast I'm moving right before I hit the ground. So this is where I'm starting. I will write my equations now. So there's my setup. I don't really need my picture anymore. I've done what I needed to for that. I'm going to start with blue. I'm looking for the time, and if I'm looking for the time, I can't really use equation 2. I can use equation 1, and let me do that actually. Okay, what I do know, y final is going to be 0, v initial is going to be 0, so I'm solving for time. Out of this equation, I'm going to get time equals negative 2 y initial over a, all under a square root. I will tell you probably the last time, if you need a moment, if you don't immediately see how you get from that first line to the second line, then pause the video, do the algebra, and get to here. So now I'm going to get -2 times y initial of 20 meters over -10 meters per second squared. 2 times 20 is 40. -40 over -10 is +4. Take the square root of that, I get 2 seconds. So the time for blue is going to be 2 seconds. Next one, purple. I have, again, the same information as I did before. I'm going to use equation 1 again. Y final, Y initial, V initial t, half a t squared. My Y final is going to be 0. I'm coming to the ground. V initial is no longer 0. It's +10 meters per second squared. So now I've got an equation where I have a 0 term, or I have a non-t term, I have a t term, and I have a t squared term. This looks very much like I'm going to need a quadratic formula, and I am. Quadratic formula says take all of the variables, all of the everything in the equation, and move together to one side. Set the other side equal to 0. And that's what I've got already. I've got 0 equals. Now I would like to arrange things so that they are in order of decreasing powers of t. So I'm going to start with the t squared term, which is going to be a half of my acceleration, so half of -10 meters per second squared. Plus my regular t term, which is V initial. V initial for purple is 10 meters per second. And then plus my constant term is just Y initial. My Y initial is 20 meters. What my quadratic equation says is that I want 0 equals x squared times a plus x times b plus c, or ax squared plus bx plus c. And then it says that my x, or in this case my t, is going to be -b plus minus square root b squared minus 4ac all over 2a. So what I get here, my a term, is going to be half times -10. My a is going to be -5. My b is going to be 10. My c is going to be 20. When I plug that into my quadratic equation, I come out with a value. I do have that plus minus in there, so I'm actually going to come out with 2 values. What I get is that my t is going to be either -1.24 seconds or 3.24 seconds. The reason I'm getting 2 values is because my quadratic equation doesn't know that I'm doing physics. It just says I have this equation. That equation plots out a parabola. It's finding this time, that's my positive 3.24, but it doesn't care where the initial launch was. It also says, well, if I trace time backwards, that could have been another time that I crossed. That's what the -1.24 is about. It doesn't make sense from a physics standpoint, and that's not the value we use. So we're going to get 3.24 seconds. Last one, orange ball. Now I know we just did this purple one, and that it's going to be very, very similar, but I want to give you a little bit of a different approach. For the purple one, I used equation 1, and I got to a point where it was a quadratic. I had to use equation 1 because I didn't have v final. If I had v final, then I could use equation 2. So what if I started this problem and said, let me find v final? I know it's not what I'm being asked to find, but let me try it. I'm going to rewrite these variables over here on the right side just so that I can move the thing off screen a little bit. So I'm going to find v final using equation 2, or using equation 3 rather. I'm going to say v final squared is v initial squared plus 2a delta y, and I can just plug in already, right? V final is going to be the square root of v initial, so 10 meters per second squared plus 2 times the acceleration times delta y. Y final minus y initial, so I'm ending 20 meters below where I start. Negative 20 is my delta y. I'm going to take the square root of that whole thing, and I'm going to get that my v final is plus or minus, I've got that square root so I have to be careful about that, plus or minus 22.4 meters per second. Thinking about physically what's going on, I have a ball, I threw it straight down. When it gets close to the ground, it's moving downward. I actually want the negative value here. So my v final is going to be negative 22.4 meters per second. Now that I have v final, now I can use equation 2. I'm going to take these things and just move them out of the way a little bit. I'm going to use equation 2. Equation 2 says v final is v initial plus acceleration times time. Time is now the only variable in here that I don't know. So time is v final minus v initial over acceleration, negative 22.4 minus negative 10 all over the acceleration, negative 10 meters per second squared. And I get a time of negative 22.4 plus 10 is negative 12.4 over negative 10 is 1.24. I get a time of 1.24 seconds. I did have to solve for something right here, this v final. I did have to solve for something that I wasn't asked to find, but in doing 2 steps instead of 1, I avoided having to do a quadratic equation situation. I'm going to go all the way back to the start and actually answer my question. I'm looking for the time difference between the impacts. The blue hits at 2 seconds, the purple hits at 3.24 seconds, the orange hits at 1.24 seconds, and that makes sense. The orange should hit first. I'm throwing this thing downward, then the blue, then the purple. So orange first, and then from 1.24 to 2 is 0.76 seconds later. Blue, 0.76 seconds later. And then the purple will hit last, and that is from 2 to 3.24, it's 1.24. those are my time differences, and that's really a good way to be able to solve all three of these problems, kind of three different methods.